Yes, we shall begin with this chapter. As you can see the heading, this is our last inorganic chapter which is pending. That is general principle and process of isolation of elements, commonly called as metallurgy. If you are interested in extraction of metal and working in the industry, this can be taken as one subject. They study as one whole branch, okay, like how we have chemistry as one subject and then we have physics and maths. Now you're studying that separately, so this metallurgy has studied as one whole thing, where so many extraction processes, the new methods, okay, all that is studied in detail. So it can be studied for no around 5 to 6 years. You can do the study only on metallurgy. So it is a very vast topic. Basically it's a very vast topic, but you are going to give get the gist of everything here, how the extraction has been done, okay, and the different extraction techniques for different metals. So let's see what is metallurgy. What does metallurgy has to tell you about this? Metallurgy is it is a process of extraction of metals. Okay, you are going to learn about process of extraction of metals from its ore. From where? From their ore. As you can see here, from the mining place they extract this. They will take that ore and come, and then they put in that furnace. They try to apply certain methods and finally try to get the metal out of it, and then you will start utilizing that metal for so many other purpose. So that whole process is called as metallurgy. Okay, so I have not put the definition here. I'll send you that PDF later. Okay, the notes PDF, I'll send it to you later. So metallurgy on the whole, if you want, I'll write it over here. Okay, so that you can copy it down right now instead of waiting it for later. So it is a process of extraction. It is a process of extraction of a metal, process of extraction of a metal from its ore, and its utilization. And its utilization is called as metallurgy. Utilization for so many other purpose. Why we have to extract? Because we need it for our day-to-day life to use it. You know the vast uses of metals. At home, most of the utensils what we are having is made up of metals. If the house has to be constructed and the engineering, everything, they need this, no? And even in the industries, the machinery parts, the automobiles, okay, so many things, if I have to list, there are so on. Okay, so just for our sake, for our benefits, for our requirements, we make use of these metals. So for that sake, it has been extracted from their ores. So that is for utilization sake. So everything will be categorized under metallurgy. Now few terms you should know related to this. There are few terms which you have to learn. First one is about minerals. What are minerals? See, whatever you get from the earth crust, whatever you obtain from the earth crust, any chemical compounds, what you are getting from the earth crust when you do the mining, okay, that can be categorized as minerals. So minerals are nothing but naturally occurring chemical substance in the earth crust. As you can see, all of these can be called as mineral. If you just take a stone also, that is a mineral for us. Okay, so whatever you are getting from the nature, whatever you are getting as a chemical compound from the earth crust, that is called as minerals. Okay, then the another term which you need to be familiar is what is ore. So there is a lot of difference between minerals and ore. Now ore is something from which you can get metal. Okay, extracting metal in such a way that it is conveniently got and it is economically profitable also for you. Now imagine you got one stone, and or one person has got one stone, okay, and they thought that it might have gold content in them. So they will have to implement certain chemical methods so that they can extract that gold from that. So now whatever gold he is going to get at the end, and the amount of kharcha he has done there, means the amount of investment he has done for that extraction, if that investment is more than whatever profit he has got, then it's a waste for him. It was not economical, right, for him. It is actually like he will be under loss if he has to do that extraction, because a lot of waste he might have got. He got one stone, okay, from that only 5% of gold has been obtained, and the amount of money what he has put for this extraction has become more, okay, then the amount of gold being extracted. So then he is under loss. Then that cannot be called as ore. So the minerals from which metal can be extracted conveniently and economically, means you should get finally a profit out of that. So imagine now the ore has been obtained and 95% of that is the pure metal there. Okay. And the amount of investment which he has done for extraction, compared to that he has got a profit. That means it is an ore. Okay. So ore is something from which you can get metal conveniently and it is profitable for them, for us. So there are difference between ores and minerals. So you can call all the ores as minerals, but you cannot call all the minerals as ore. Okay. So ore is only from where you can get profit. So all the minerals are not ores, but all the ores are minerals, because that we are getting from the earth crust. Is this followed, students? These definitions are followed. These terms are understood to you. One is the mineral and the other one is the ore. Okay. So minerals are anything which you are getting from, I'll just quickly revise here only. Minerals are something which you are getting from the earth crust through mining if you are able to obtain. And ore, I said, if only you are able to get a profit out of that, that can be called as ore, and which can be easily extracted, conveniently and economically extracted. So we can call all the ores as minerals, but we cannot call all the minerals as ore, because they might be containing so many unwanted things which is not no beneficial for that particular person who is planning to extract it. Okay, next what we are having is, now when you are planning to extract the metal from the ore, they will be associated with so many unwanted things. If you go to the mining industry, see, they are nothing but the stone, no? It will look like a stone only. For us, everything will look similar, because we don't have that idea of what kind of, no, what kind of metal ore it should be. Okay, we don't study in detail about that. No, when you start studying in detail about each and everything, you will understand, okay, this particular, no stone which I have got contains this kind of a metal and can be extracted in this way. But when you see them, it is just like a stone for you. So that stone will be associated with so many unwanted impurities. Earthy impurities will be there, like clay will be there, sand particles will be there, soil will be there. So many things will be associated with that. That is called as gang. Okay. So you have to spell that as gang there. That UE is silent. Okay. It is gang. So ore is contaminated with so many earthy impurities. Those earthy, or the ore which is associated with many earthy impurities, that is called as gang. Okay, it has to be removed. Later we have to remove this gang particle so that you will be able to get the metal out of it. These are the different kinds of ore which I have put here. See, bauxite is for aluminium. We have beryllium here. See, all are the different. I will not start listing it. These are the ores because it's not important for you. Next, what we have is flux. The next thing, flux is a substance which is used to remove the gang. Sometimes the gang is difficult to be removed. Just like that, you will not be, see, because you will crush that. What they do is, initially they will crush it, and then it will be in the powdered form, which will have the metal, plus there will be these particles also. So you need some substance which will combine with that gang, and it will be removed out easily, okay, without removing that metal from that. So those are called as flux. So flux are those substance, these are those substance used, these are those substance which are used to remove the gang. It is used, you can write it down, because I don't think so these definitions are there in that printed notes what you have, and then even I don't know about that Xerox, I should see. Okay, so you better make a note of this. Substance which are used to remove the gang in the form. Now that new compound which is formed is called as slag. I'll tell you what slag is. In the form of slag is called as flux. Means when you combine this, when the flux combines with the gang, when they combine with this gang, what you get is called as slag. So slag is that unwanted compound which is produced due to combination of flux with this unwanted impurity. So that has to be thrown out. I have put a picture over here. You can see, this picture is for extraction of iron. It's a blast furnace. This furnace is called as blast furnace. Later again, I'll be talking about this. Okay, this huge furnace is called as blast furnace. From here, from this side, everything will be fed. From this side, feed that raw materials, they put that, okay, whatever materials we are supposed to add, no, the ore, the flux, everything will be added from this side, okay, and then they are allowed to heat at very high temperature, reaction takes place, and if your unwanted impurity is present here, that will combine with the flux, okay, and it will come out in the sea. From here it will be floating up, and that will be removed first, and your pure metal will settle down at the bottom. So that will be removed from this end, and this slag part will be removed from the another end. You can see here, okay, that's how the arrangement is made, because slag usually are little denser than compare. Your metal is more heavy, no, metal is more denser. Okay, now one example which I have taken here. See, limestone is used in the extraction of this iron. When they are extracting limestone, breaks down in the form of calcium oxide, and it combines with that sand. Sand is nothing but silicates. So SiO2. See here, calcium oxide is combining with the silicon dioxide, forming calcium silicate. This is calcium silicate here, which is the slag. And that is been removed out. Calcium silicate is thrown out. See here, I've shown the picture of slag. You can see this slag. This is that extra material which is being formed during the reaction. It will be very hot because you are heating the furnace at 2000, 3000 degree, 5000 degrees Celsius. So hot it will be. Okay, so these unwanted impurities will be thrown out. So after they cool down, it may look like a stone only. Okay, piece of stone. So they are even used in concretes. Instead of throwing it out and wasting it, you can use it so that we can have a sustainable, okay, sustain, no, like it is not a waste. Your whatever we are getting as a side compound is again reused, okay, recycled again. So these can be used with concretes, they can be used in constructions. So slag is not basically a waste. It is waste during the extraction process, but then it can be reused in different forms. Okay, so it is a fusible, I can say it is a fusible mass which is obtained. It's a fusible mass which is formed by the gangue and the flux. The gangue and the flux. This much is understood, no, students? Shall I proceed with the next? It's easy because this will be more interesting for you, I know, because we are having this in our daily life. It's a daily life application thing. Only few equations are there which you will be having to study. Otherwise, I feel it's more interesting because you can apply in your daily life. Okay, this is happening. Few things which you're not able to see, difficult to sometimes take in. But these things are easy to understand also. Okay, now we'll move on with the next. I believe it is understood. I'm going with the one who are replying to me. Okay, now one question to you all. Can you tell me which is the most abundant element in the earth crust? Which is the most abundant element in the earth crust? It is an element, I'm asking, only in the earth crust. Think and answer me. Which is the most, don't do the research there, don't search. Whatever you know, you answer now. Which is the most abundant element in the earth crust? I need that spontaneous answer. I don't want you to search and then reply to me. Then it is of no use. Then it's not fun. Nitrogen, krypton, gold, aluminium. Element you are saying. Element means you will have everything, no? The 118 elements will come there from the periodic table. Okay, majority are saying me it is nitrogen. Oxygen, one answer I've got. Iron. These are the different options which I've got. See, nitrogen I've got. Good that you people are replying. Anyways, it's right or wrong, it doesn't matter. You just reply. Okay, nitrogen, iron, krypton, oxide, gold, aluminium, oxygen, nitrogen, diamond. Joel, very smart. One of the element in the periodic table. I'm asking that element. Majority are saying iron. Majority are saying iron. And then I have copper also here. Now let me tell you. Okay, there are two people have answered me correctly. The element which is most abundant in the earth crust is the element which is required for the life to exist. Now, if everyone can reply, it is an element which is required for the life to exist. Yes, oxygen. That is the most abundant element. Yes, I have got Revan and Benson answering it correct. Yeah, oxygen is the most. See, it is not available in the free form. I'm talking about overall in the earth crust. It might be in the combined form, it might be in the free form. Okay. Nitrogen is the gas which is available in abundant quantity. It is in the gaseous form there. But oxygen is combined form as well as in the elemental form. Overall, when you find out, this element will be in the large quantity. Because see, 70% of our earth crust has water, and in water there is oxygen present. Plus we are having the land which is made up of silicates, correct? Silicates it is, silicon and oxygen, so there also oxygen is present. And most of the plants and animals are composed of carbon, hydrogen and oxygen is present, so oxygen becomes one of the most abundant element. Any idea about that second one? Very good, oxygen is the correct answer. Second most abundant element again. Second most abundant element in the earth crust. Second most abundant element in the earth crust. Okay, one option I've got carbon. What about others? You can reply. Element, not a compound. It should be an element. Carbon dioxide is a compound. See, the answers which I'm getting: silicon, hydrogen, carbon, iron. Okay, I'll give you the answer. Okay, hydrogen. Again, hydrogen. Hydrogen is the most abundant in the universe. I asked you in the earth crust. So, silicon is the correct answer. Silicon, Nadir has answered for silicon. Silicon is the correct answer. Silicates, land we are having, no? That consists of silicon, right? But in combined with oxygen, that's fine. But silicon is the second most abundant element, okay? This you can remember, students. It could be asked also. It could be asked. Okay, so oxygen is one of the most abundant element. You can write down, write as a note. Oxygen is the most abundant element in the earth crust. Element it is, and silicon is the second most abundant element in the earth crust. Now, next question is, which is the most abundant metal in the earth crust? Now, I won't give you much time. Quickly, if you know, you answer. Okay, aluminium, iron, aluminium, iron. Then anything else? Anything else? Aluminium. Okay, majority are telling me aluminium and iron. Aluminium and iron, most of them. Nickel. Okay, one more nickel I got. Aluminium is the correct answer. Majority. I'll go with majority. Very good. Aluminium is the correct answer. See, the one who is abundant, they will be cheaper, no? And you know, aluminium is one of the cheapest element we are having. Aluminium is one of the cheapest elements. So, aluminium is one of the most abundant element in the earth crust. The one who is abundant, they will be available for cheap. Okay, you can buy it easily. But once the amount starts decreasing, then the cost starts increasing there. Second most abundant, their other element what you had mentioned was iron. So iron is the second most abundant element. So we have no, ions are also used in construction because it is cheap. Then because they are abundant, so they are cheap. Okay, so first abundant metal in the earth crust is aluminium. Second most abundant element in the earth crust is iron. Just make a note of this quickly. Yes, we'll move on now. So this is the flow chart which I have put pie chart, I can say. The different elements which are present in the earth crust. You can see oxygen is more. Oxygen is more. Then we are having silicon. This is overall for the elements. Otherwise, metal wise, if you see, it is aluminium first, followed by iron. Then you can see the other elements in traces. We'll move on with our next part. Next part is we are moving on with the extraction process. Okay. So extraction has different steps are there for extraction. First step is concentration of ore. If you want to finally get the metal out of that ore, you need to have certain process for that. You need to clean that ore first. No? Like when we buy a vegetable, we directly don't start eating it without, no, we have to clean it, correct? First the cleaning has to be done, then the cooking has to be done. Okay, then finally the last step will be the eating part. So here also, when you are getting that ore from the mining industry, the first thing what has to be done is the concentration of the ore. So concentration means it is a process of removing the unwanted impurities. Okay, it is a process of removing the unwanted impurities like sand, clay, okay, whatever is associated with that is called as concentration of ore. It is also called as dressing or benefaction of ore. These are the different names they are using, concentration or benefaction of ore. So different concentration methods we are having to study. These are the 4 concentration methods which you need to study. One is hydraulic washing. I'll just mark here. Then magnetic separation we have, froth flotation, and then the last one is the leaching process. Okay, so these are the different concentration technique. Concentration means removal of unwanted material. Like I said, when you bring the vegetable at home, first thing what you do is washing, because you want to remove whatever is associated with that. That itself is concentration. Okay. So removing the unwanted impurities. Let's see first one, hydraulic washing. You can tell me what is associated with this hydraulic washing. With the name only you can understand what it will be. It is just that you are washing it with water. Hydra stands for water, right? So from the top, you can see from top they have powdered the ore. Yeah, related to water, correct. So they have powdered the ore, and from this side you can see water has been continuously passed. So whichever particles are light, they will be washed away, and these heavier particles will settle down. So clay particle, dust particles, all that will be washed. This is similar to like when you want to cook the rice, what we do? We take the rice in the bottom and then we allow the water to flow there, correct? When water flows over there, the dust particle, the sand particles, that small ones, clay particles and all that will start floating. And if there are small insects and all, that also will start floating. And then it will be thrown away, correct? So that's how hydraulic washing is also done. It's a basic technique what we do in our daily life also, similar to that only it is. Okay, see here there is different ways. The arrangement might be little different industries will have different arrangement, but the concept and the principle is same, that lightweight particles will be floating at the top and they will be just thrown out, and the heavyweight ore will settle down. So like that, at least little part of the cleaning can be done. See here one animated picture I've shown. Are you able to see it properly? You can see the rollers inside, and from this side the powdered ore has been thrown, like they are putting it from this side, and then continuously that inside that water, because when you are doing it in a large scale, the ore has to be mixed properly. Hope you are able to see this, students. Everyone, are you able to see this? It's just an animated picture, but still it will give you an idea. So heavier one will settle down and the light particles will be thrown away. Okay, so that's hydraulic washing. It's easy to understand also. Second one is magnetic separation. Again, go with the name. Magnetic separation are for those metals and for those ores who get easily attracted by the magnetic field. Okay, so this is based on the difference in magnetic properties between the ore and the gangue. Both should not get attracted. Okay, so or neither both should be not getting attracted. One of them should get attracted by the magnetic field and the other one should not get attracted by the magnetic field. Then like that, with those we can do the separation. So I said there should be a difference between the magnetic properties in the ore and the gangue. Okay, one should get attracted and the other one shouldn't get attracted. So these powdered ore, again from this side, you see from the right side, You can see a funnel kind of an arrangement. From this side, the powdered ore is being fed. When the powdered ore is being no, passed through this is a magnetic roller. This circular one, you can see it will be moving on. It's a belt. Okay, so it is a continuous belt, so it will be continuously going on. Okay, it will be rolling, and when you pass this powdered ore over here, the one which is having magnetic property, they will get stuck to this roller, and the one which is not having any attraction towards the magnetic field will be thrown away. So you can see here they are thrown away on this side, like this they will be thrown away on the other side, and the one who got attracted will be collected on the right side. Okay, these will be thrown away towards the left side. So non-magnetic material and magnetic material get separated. So most of the time it is applied for iron. You know, iron easily get attracted by the magnet, so iron can be separated. Okay, so here I already told you, either the ore or the gangue particle should be capable of getting attracted by the magnetic field. So then this separation can be carried out. Otherwise it is of no use. So most of the time I said for iron it has been done. So grounded particles are being passed through this belt, and then completely whichever is getting attracted comes near towards the right hand side, it is collected, and the other one is collected from the left side. See here, I have shown this. This is the animated picture of that. These black color particles are the iron particles. So as it is rolling, the one which is non-magnetic will go on this side, and the magnetic ones will get attracted towards this, and it will be removed out. These two separation techniques, I believe it is understood to everyone. We'll go with the third one now. The third one is froth flotation. Froth flotation technique. So froth has to be formed over here. This is the diagrammatic picture. See, I have shown here. This is a diagrammatic picture which we are having for froth flotation. Now, which type of metals are being extracted through this? Most of the time, the ore which are extracted, concentration of which ore is done is concentration of sulfide ore is done. Concentration of sulfide ores are done through this method. Okay, like zinc sulfide, then we have copper sulfide. These are the different sulfide ore. Remember, froth flotation is applied for sulfide ores. This also could be asked. Which ores are basically, okay, separated or concentrated through froth flotation? That's sulfide ore. Example I have mentioned here, zinc sulfide and copper sulfide. So you can see here, this arrangement, you can see it is having a vessel. It has a huge vessel here, and it has an agitating instrument. You can see this side, it is having that. It can be rotated. Okay, this can be continuously rotated. This whole thing can be continuously rotated. It has a hole, that is so that they can take air and pass that air throughout the mixture. Okay, so it will be continuously rotated, and it consists of what and all they will add to this. Along with the ore, just remember, along with the ore, they add few drops of collector. I'll write here. I'm writing on this side. You can make a note of these. Few drops of collectors are added. That collectors are added to collect the sulfide ores. Okay, they are added to collect the sulfide ores. So those collectors can be pine oil. What are the different collectors can be added? Pine oil can be added. Fatty acids can be added. Xanthates can be added. These are organic compounds only. Okay, xanthates can be added. These are the different compounds which are added so that you can collect the sulfide ores along with it. And then these sulfide ores are in the colloidal form. Do you remember I've told you sulfide also? Sulfide you have studied there in the colloidal part. Sulfide can be existing in the colloidal form also. And sulfide existing in the colloidal form is quite unstable. So which category they will come under? Lyophilic or lyophobic? If they are unstable, it will come under lyophilic or lyophobic. Yes, very good. Lyophobic, correct. So they are lyophobic. If they are lyophobic, they need something, no? What do they need? If they are lyophobic, I am expecting the answer from you people only. If they are lyophobic, they need something. They have a phobia, so they cannot be existing alone. What is that? Another substance which should be added along with it. Starts from as a stabilizer. So they need a stabilizer. So here, along with this, you need to add a stabilizer. That's aniline here. aniline is added, or cresol can be added. Again, organic compounds only, stabilizers are added. Okay, because sulfide ores are quite unstable. So if you want them to exist in that colloidal form, they are added with the stabilizers. Okay, so these stabilizers will keep them in that colloidal form. And now how the mechanism takes place, see how is the working part. This is similar, for me it is similar to if you have seen how butter has been extracted, the olden technique. You all know no, how butter is extracted from that olden technique. They used to agitate it continuously with this. See, this is that the long stick, and then they had a fan like arrangement is there. So continuously when you agitate it, the butter part will start floating at the top. Agitating means the air will combine with this thing, no, the butter, and then it forms the froth. At the top it will form that froth, and then that froth is being removed out, and your butter will still remain at the bottom. That's how it is. Okay, so this agitation, the froth flotation process is having a similar process there, similar method it is. See, if you see, observe this long stick is there, no, that will be continuously rotated. Okay, it is agitated like a fan. You imagine now, like that only it will be rotating. So when continuous rotation happens, these collectors which are there, it will combine with the sulfide ore, and it will start floating at the top like a froth. See here, a froth will be formed at the top like this, and whatever heavy particles are there, no, heavy particles will settle down at the bottom. Like how I told you, butter will start floating at the top, and this curd will settle down at the bottom because they are a little heavier. Butter is light in weight, so these sulfide particles will be floating at the top along with your that pine oil, everything, no, the collector and the stabilizer, everything will be stabilizing them, and it will be at the top. So that has to be removed out, and these things will be settling down at the bottom. Is this understood how the working is happening? Yes, okay, fine. See now here, this is the sulfide ore. You can see this side, you can see this one where this one, see here. I'll just mention with the arrow mark. This is that agitating pipe. Okay, that agitating pipe is over here. So this will be continuously rotating. When they rotate along with the sulfide ores, that sulfide ore will come. See, you can see the froth, no, how it is. This looks like a gutter, but this is a froth, okay, because it's an ore. The ore color is silver in color, no? So when continuously which is agitated, you will be able to see that froth on the top, and this has to be skimmed off. You have to remove it out. Okay, this is how it will look. And now one more thing to note, what if the ore contains two sulfide ore? Imagine there is zinc sulfide. I'll write it over here. I don't think so you'll be able to see it. Now, if there is two sulfide ore, imagine there is zinc sulfide and there is lead sulfide. Two sulfide ores are present. Then both of them will come together. No, then separation becomes little difficult. So in that case, what they try to do is one has to be suppressed. Means one has to settle down at the bottom and only one should come up. So for that sake, they add a depressant. Depressant is added. Example for depressant is NaCN. So this NaCN will combine with the zinc sulfide, and it will allow only the lead sulfide to go up. Okay, so lead will easily combine and zinc will combine with NaCN. Then later on it has to be extracted, removed. Okay, so that is the job of depressant. Depressant does not allow both the sulfide, it will allow only one sulfide ore to come up. Okay, so that is froth flotation technique. I hope it is understood. I'll just repeat it once again for you. I said froth flotation is a technique which is applied for concentration of sulfide ores. It is applied for concentration of sulfide ores, like zinc sulfide, copper sulfide can be concentrated through this technique. So what they do is they completely, like continuously, they agitate this mixture. Okay, rotation is being done. So when the complete rotation is done, agitation is done in the presence of air, with a certain amount of collector, you need something which where the sulfide will combine with. So a collector is added, like pine oil, fatty acids and xanthates are added. So this will wet the sulfide ore, means it will combine with them. It will easily combine with them. Sulfide ore will be soluble in this. Okay, it will wet them and it will combine together and it will form that froth. And to stabilize that froth, you need a stabilizer. So aniline and cresols are added as a stabilizer, because otherwise it's quite unstable. It may coagulate and fall down. Then it's difficult for us. Okay, so a stabilizer is added. And it will be floating at the top. It will be like a froth. As I said, how butter is been extracted in the olden techniques, they used to continuously agitate it. So the lightweight ones will be floating at the top and the heavier ones settle down, and then it has been skimmed off. The butter is been taken out. Same method has been applied here also. The lightweight particles of the sulfide with the collector and everything will be floating at the top. But if there are two sulfide ores, I said, then they have to like suppress one. So a depressant is added. So when a depressant is added, the zinc sulfide ones will be suppressed and the lead sulfide ones comes out easily. Hope I have made this much clear, students. Did you follow in this general principles or metallurgy? Till here, is it understood? Yes, no? Okay, very good then. Then I'll stop here and I'll continue tomorrow. Okay, we'll continue tomorrow. Tomorrow also, I think it will be online. They have not told us anything. Unless we get a message, I can't tell you anything. Let's see. Okay, we'll wait till the evening for the message. If there is offline classes, it will be told, and then I'll intimate that to you. If nothing is there, then online will be continued. You want to come to college? But now this was told by the CM, no, because of all these problems which is happening. Okay, let's see. No, no, like that you don't come to the college. See, unless it has been told, don't go and sit in the college. Okay, then it will create another trouble. Everyone coming together is fine. Yes, okay, then we'll stop here. Okay, we'll continue tomorrow. Keep reading, keep reading, keep utilizing your time. This is my no daily mantra which I'm telling you. So see that you don't waste your time. And I want one of you to post that questions in the group. Put that question in the group, and so that you are ready on Monday with these questions. The 20, 21, 22 marks question which I have put. Okay. Immediately somebody just post that question. It's a reminder for everyone. Because some were absent on that day, so that everyone knows what they have to study.